Number 12 has a basketball, and we're shining a light on this basketball. And as we shine that light, we're going to rotate that flashlight around the ball. Now, question number 12 and number 13 are really the same problem. The difference is in question number 12, we're rotating the cone, essentially. And in question number 13, we're rotating the plane that intersects the cone. But they're essentially the same problem. It seems here that the answer is incorrect because they say that the angle formed by the light rays is always 40 degrees, but the answer is based on a 90-degree angle made with those light rays. Okay, so I think this is incorrect based on the answer that's given in the answer key. So as I'm going to show you an animation of this as well. So that animation is slightly different in that the animation is going to measure that little blue angle in here. And whereas this problem measures the angle made with that green perpendicular line and the angle made with the axes. Now, the way they set it up is a little bit confusing in that it's hard to follow that angle, but that's not important. It's important to understand that as the angle changes, we're going to cut through that cone differently and get different shapes. So in the animation, when I show you in the next video, is going to be the angle that's shown is actually the blue angle, not the green angle that we're being asked to solve for. So in this case here, if we want to get a circle, we want to shine it directly from the top. That means the angle is 0 degrees, or from the very bottom, which is 180 degrees. And as we increase that angle all the way to 45 degrees, we're going to have an elliptical shape. So from 0 to 45 degrees, I'm just going to write like this, 0, 45. We're going to have, in that domain, we're going to have an ellipse. And as we go around past 45, we're going to get a parabola and hyperbolas, and then when we get back to it looks like it'd be 135 degrees. So from 135 degrees all the way to 180 degrees, we're going to get an ellipse, and then we'll have that mirrored on the other side as well. We're just going to look at that first half of the circle though, but we get a mirror image on the other side of the circle. Now the key is a boundary, is a parabola. The parabola is going to be formed when the cone angle matches the rotational angle. Okay, or it's actually the half the cone angle matches the rotational angle. So at 45 degrees, we're going to get a parabola, and these are important. Okay, so 45, 135, and all the 45-degree positions as we go around the circle. Okay, so that's going to give us the parabola, and this is important because the parabola is a boundary between the ellipse and the hyperbola. So as we get past 45 degrees, so from 45 degrees to 135 degrees, we're going to end up with a hyperbola. Okay, so at 135 we get the parabola, and from 135 to back to 0 we get, so 135 to 180. Okay, we're going to have hyperbolas, and again that's just the first half of the circle, so we're just going to that's going to be mirrored in the second half of the circle.